Hey guys, 48 hours ago, we released a question that only the top 5% of Year 11 students could answer. If you haven't seen it yet, pause this video and click the link in the description to watch that first. So if your answer was 13.8 meters per second, then you're wrong. If you got 13.8 meters per second to the right, you're still wrong. The answer is actually 1.2 meters per second to the left, and here's why. So we've redrawn the diagram here, and remember what we're trying to find is the velocity of the train relative to person B. So in our notation, this is VTB. Okay. So to figure out this answer, we're going to use our standard relative velocity formula equation. So what is that formula? It's VAB is equal to VAX minus VBX, where X is the intermediate frame of reference, usually the ground. So to find VTB, we're going to plug this into our standard equation, and we're going to get VTG, the velocity of a train relative to the ground, minus the velocity of person B relative to the ground. Now, the reason why most people got 13.8 meters per second is because they thought this was VTG, which it is, and they thought VBG was this 1.2 meters per second. But in reality, this is not actually VBG. This value here is the velocity of the person B relative to the train. Remember, person B is on the train and he's walking at 1.2 meters per second. So that means that's his velocity relative to the train because he's on the train. Okay, so we have VTG, but we don't have VBG yet. So the first step is find VBG. So how do we find VBG? We're actually going to use our relative velocity formula again, but this time for this value that we have of 1.2 meters per second, which is actually VBT. So we're going to use our standard formula and say VBT is equal to VBG minus VTG. Okay. Now we want to find VBG, so we're going to make VBG the subject, and we get VBG is equal to VBT plus VTG. We can substitute our values in. We have 1.2 to the right, so we'll put a little arrow to the right, plus velocity of the train relative to the ground, 15 to the right, and this is going to give us a total of 16.2 meters per second to the right. Okay, so what did we just find? We just found the velocity of person B relative to the ground, which makes sense because if you look at our diagram, person A is on the ground and he's watching person B. So the speed of person B relative to the ground is going to be his speed on the train plus the train speed, which gives us 16.2 meters per second. All right, now that we have VBG, we can now plug it into our original equation to find VTB, the velocity of the train relative to person B. So VTB is equal to VTG minus VBG. We have our velocity of the train relative to the ground as 15 meters per second to the right, minus 16.2 meters per second to the right. Now, to subtract this, we're going to flip this vector around. So we have 15 to the right plus, and we're going to flip this arrow, 16.2 to the left, which gives us a net answer by vector addition of 1.2 meters per second to the left. So now that we've found the velocity of person B relative to the ground, we can plug it back into our original equation. The velocity of the train relative to person B is equal to the velocity of the train relative to the ground minus the velocity of person B relative to the ground. So we plug these numbers in, we have 15 meters per second to the right minus 16.2 meters per second to the right. Now with vector subtraction, all we have to do is flip it around to the other side and change the minus to a plus. And we add the 15 to the 16.2 going in the opposite direction, and we end up with 1.2 meters per second to the left. So our answer is 1.2 meters per second to the left. 95% of people will think the answer is 13.8 meters per second, but the answer is actually 1.2 meters per second to the left. Now let's try and figure out, does this really make sense? And the trick is, if you're standing in the train, pretend the doors are closed, right? And you're just walking 1.2 meters per second in the train. If you're walking 1.2 meters per second in the train, then the velocity of the train relative to you walking is just going to be 1.2 meters per second back at you. The speed of the train actually doesn't matter at all. Alright, did you get the right answer? Hopefully you're in the top 5%. That was the extended explanation using our standard relative velocity formulas, but there is also a shortcut to the question. If you know it, comment it below. And if you have any further questions or challenging problems, then let us know in the comments or message us. Thanks.